Beneath Yellowstone's breathtaking beauty, where geysers erupt and wildlife roams free, lies a secret far more powerful than most visitors ever imagine. Hidden deep below the surface is a colossal supervolcano, a force of nature that has shaped the land for millions of years. This is not just any volcano, it's a simmering cauldron of molten rock, stretching for miles beneath the earth, its heat fueling the park's famous hot springs and geysers. The magma chamber beneath Yellowstone is so vast it could swallow entire cities. Imagine a space large enough to engulf Chicago, and then some. This hidden power is both awe-inspiring and humbling, a reminder of the planet's raw energy. If unleashed, this natural threat could send shockwaves across continents, reshaping the very face of the Earth. The forces at play here are capable of moving mountains, splitting landscapes, and altering the course of rivers. Every day, we walk on a thin crust, blissfully unaware of the cataclysmic force that slumbers just below our feet. The ground may seem solid, but it is only a fragile barrier between us and unimaginable power. Over the past 2.1 million years, the Yellowstone caldera has erupted in 3 cataclysmic events, each one reshaping the landscape and sending ash clouds across continents. These eruptions left behind scars that scientists still study today, searching for clues about the next possible event. Today, we live in an era of calm, surrounded by serene forests and tranquil lakes. But this stability is only an illusion, a brief pause in a cycle of violent change that has defined Yellowstone for millennia. Imagine waking up to news reports of unprecedented seismic activity in Wyoming. The ground begins to swell, rising inches, then feet, as scientists scramble to understand what's happening. People gather, anxious and uncertain, as the land itself seems to breathe and shift. This scenario isn't meant to incite fear, but to inspire awe and understanding. The immense forces at work beneath Yellowstone are part of the dynamic processes that have shaped our world for eons, building mountains, creating continents, and driving evolution. Deep within the earth, a plume of hot mantle rock rises, feeding the magma chamber and building pressure year after year. This relentless movement is invisible to us, but it is always there, quietly fueling the giant beneath Yellowstone. The ground above swells and cracks like bread rising in an oven, a subtle but constant reminder of the energy stored below. Scientists monitor these changes closely, searching for signs that the sleeping giant may one day awaken. If this energy were ever released in a full-scale eruption, it would trigger an event of unimaginable scale, altering not just Yellowstone but the entire planet, and forever changing the course of human history. The first sign of impending disaster would not be a sudden explosion but rather subtle, ominous whispers from deep within the earth, a swarm of earthquakes barely perceptible at first, rippling through the ancient rock layers beneath Yellowstone. These tremors would be the planet's way of sending a warning, a message that something immense is stirring far below the surface. Over days and weeks these tremors would steadily grow in both frequency and intensity, their epicenters creeping ever closer to the surface. Scientists monitoring the region would notice a dramatic uptick in seismic readings, with hundreds, perhaps thousands of small quakes rattling the ground each day. Tourists visiting Yellowstone would begin to feel the ground shuddering beneath their feet, a sensation both thrilling and terrifying. Geysers, the park's iconic features, would erupt erratically, some shooting higher than ever before, others falling silent as underground plumbing is disrupted by the shifting earth. The Yellowstone River, usually a serene ribbon of water, would start to heat up, its surface steaming as sulfurous gases bubble up from below. The air would grow thick with the acrid smell of sulfur, a chemical warning that the Earth's crust is being breached. As seismic activity escalates, the ground itself would begin to deform. Hills and meadows would bulge upwards, the Earth swelling like a balloon as magma accumulates beneath the surface, straining against the rock above. Roads would crack open, their asphalt splitting apart. Buildings would tilt precariously, their foundations undermined by the shifting ground. Fissures would snake across the landscape, a visible sign that the magma is forcing its way toward the upper crust. At this point, the region would become a geologic pressure cooker, the Earth's layers swelling and straining under the immense force building below. The pressure would reach a critical threshold, a point of no return where the system can no longer contain the energy trapped within. Suddenly, phreatic eruptions would begin. Violent steam explosions hurling rock, mud, and debris high into the air. These blasts would tear open new vents in the ground, sending plumes of steam and ash skyward, and blanketing the landscape in a layer of volcanic debris. Then, the caldera's ancient ring fractures, weak points encircling the heart of Yellowstone, would begin to split open. These cracks would widen rapidly, forming a jagged outline that marks the boundary of the impending eruption. In a matter of moments, a colossal column of gas, ash, and pulverized rock would rocket into the atmosphere, piercing through the clouds with unimaginable force. The sky would darken as the eruption blots out the sun, casting a shadow over the land. The eruption column would climb higher and higher, reaching over 30 miles into the stratosphere. Winds would carry the ash plume across continents, threatening to disrupt air travel and darken skies thousands of miles away. Within minutes, the towering column would collapse under its own weight, sending a searing pyroclastic flow racing down the slopes of Yellowstone. This avalanche of ash, gas, and rock would move at hurricane speeds, obliterating everything in its path. This superheated avalanche would incinerate forests, rivers, and wildlife, consuming the landscape in a matter of moments. Nothing would be able to withstand the onslaught of heat and force unleashed by the eruption. An area of over 3,000 square miles would be sterilized instantly, transformed into a barren wasteland devoid of life. The once vibrant ecosystem of Yellowstone would be reduced to ash and stone. This is nature's most destructive force, a wave of incandescent death, sweeping across the land with unstoppable power, forever altering the world as we know it. As pyroclastic flows scour the landscape, they move with terrifying speed, hot churning avalanches of ash, gas, and rock racing down the volcano's flanks at over 100 miles per hour. Everything in their path is obliterated, forests incinerated, rivers boiled away, and the ground itself reshaped in moments. The sheer force and heat leave nothing but devastation in their wake. Above, the eruption column pumps material into the sky, a towering pillar of ash and superheated gases that can reach the edge of the stratosphere. The column grows rapidly, darkening the sky for miles around, and casting an eerie twilight over the land even in the middle of the day. The volume of ash and gas is staggering, dwarfing anything seen in modern times. Billions of tons of material are ejected in just a few hours, forming a dense, suffocating cloud that blots out the sun and rains debris over vast distances. This eruption is thousands of times more powerful than Mount St. Helens, unleashing energy on a scale almost unimaginable. Even the infamous 1980 eruption pales in comparison to the fury of a supervolcano. The sky would turn black as midnight, lightning flashing within the ash cloud as static electricity builds in the swirling particles. Thunder rumbles constantly, echoing for miles while the world below is plunged into darkness and chaos. The sound would be a deafening roar, a continuous explosion that can be heard and felt across the continent. Shockwaves shatter windows and rattle buildings hundreds of miles away, while the ground trembles beneath the force of the eruption. Ashfall would bury parts of Wyoming, Montana, and Idaho under feet of powdery, toxic ash. Entire towns would disappear beneath a gray blanket, roofs collapsing under the weight, and landscapes transformed beyond recognition. Cities like Denver and Salt Lake City would receive inches of ash, halting transportation and bringing daily life to a standstill. Roads become impassable, vehicles stall, and emergency services are overwhelmed by the scale of the disaster. Air travel would cease entirely, as ash poses a lethal threat to jet engines, clogging filters and causing catastrophic failures. Airports across the region would shut down, stranding thousands and severing vital connections. Within 24 hours, the ash cloud would spread across the U.S., carried by prevailing winds. No region would be untouched, as the fine particles drift eastward, dimming the sun and coating everything in a layer of grit. The air would become unbreathable, filled with microscopic volcanic glass shards that cut into lungs and eyes. People would be forced to wear masks or stay indoors, as respiratory illnesses and eye injuries surge. Power grids would fail as ash shorts out transformers and weighs down lines. Water supplies become contaminated with ash and chemicals, while communication systems falter, leaving millions isolated and in the dark. The nation would face an unprecedented crisis, cut in half by falling rock and ash. Communities would be forced to adapt to a new reality, as the sky remains dark, the air dangerous, and the future uncertain. Post-eruption, the U.S. would be under siege by the planet itself. The primary ashfall zone would become a gray desert, collapsing structures. Major rivers would turn into sludge, causing unprecedented flooding. The agricultural heartland would be buried, triggering a global food crisis. Commerce would halt, supply chains severed, financial markets in chaos. The societal impact would be profound, with millions displaced. The government's response would be hampered, martial law likely declared. Volcanic gases would release sulfur dioxide, forming acid rain. This would poison land and water, corrode structures and harm health. The world would watch in horror as the ash plume encircles the globe. A new, darker chapter for humanity would begin. After the chaos, a long-lasting threat emerges, a volcanic winter. Ash and sulfur dioxide form a veil, reflecting solar radiation. Global temperatures drop, summers cool and wet, crops fail. The impact on food supply would be catastrophic, leading to global famine. Societies would struggle for survival, civilization on the brink of collapse. Ecological consequences would be dire with mass extinctions. The world would be colder, emptier, and profoundly different. Humanity's resilience would shine, adapting to new challenges. New forms of agriculture might emerge, communities forged in crisis. The memory of the old world would inspire and caution. Survivors would rebuild civilization from the ashes. Years later, the world would be a shadow of its former self. The volcanic winter would persist, with semi-permanent agricultural collapse. Societies would adapt radically, technology regressing. Energy would be a primary concern, relying on localized sources. The landscape of North America would be permanently scarred. The Yellowstone region would form a new mountain range. The ash layer would mark the Yellowstone event for future geologists. Humanity's resilience would shine through, adapting to new challenges. New communities would emerge, built on cooperation and hardship. Survivors would be resourceful, inheriting a broken planet. The volcanic winter is driven by sulfur dioxide forming sulfuric acid aerosols. These aerosols reflect sunlight, causing long-term cooling. Unlike ash, they remain in the stratosphere for years. The cooling effect is akin to a nuclear winter, resetting the climate. Historical precedents like Tambora show the impact of such events. The Yellowstone Supereruption would be far larger, lasting a decade. Recovery would be slow, with potential climate shifts. As aerosols clear, greenhouse gases would cause rapid warming. Survivors might face accelerated global warming. This climatic whiplash would test civilization's resilience. Yellowstone is one of many supervolcanoes capable of climate-altering eruptions. Past events like Toba pushed humanity to the brink of extinction. Geological detective work reveals supereruptions are natural, recurring events. The question is when, not if, and whether we'll be prepared. Some models suggest effusive volcanism as a future threat. Large igneous provinces could release more gases over millennia. The greatest threat might be human activity, releasing CO2 at unprecedented rates. We simulate a slow-motion volcanic eruption, altering the climate. While fearing Yellowstone, we ignore our own geological impact. We are a force capable of altering the planet on a massive scale. The universe is filled with violent, transformative events. Yellowstone's eruption is a natural event, reminding us of Earth's dynamic nature. Understanding this fosters humility and appreciation for our moment. Yellowstone's story is a lesson in interconnectedness and fragility. Our greatest strength is understanding these systems through science. We can monitor Yellowstone's pressure and model ash spread. This knowledge is our defense against hidden dangers. We must use this knowledge wisely, building resilient societies. The threat of a supervolcano should inspire better stewardship. Let's continue our journey with eyes wide open to Earth's forces.